So when we talk about levels of complexity, I'll go back to the slide that Sarah had and talk a little bit about this. The levels of complexity are going to be very important for adding thousands of shading surfaces to your file. When you're inside of Revit, you are going to want to bring through specific shading surfaces. You may have made some sort of facade design that you want to come, facade shading that you want to come through, all sorts of different things. But the way that they have to come through is in a mullion family or a roof family. Not a floor family, not a wall, I mean, wall sometimes, depends, but it has to be roof or mullion family. Why? I'm not sure. But if you have done your shading out of masses or that type of thing, it's nothing else is going to come through. So you have to make sure that if you have done something out of masses, that you're actually going to apply the roof family or the mullion family to that entity to change it into it, and then that will actually come through. And make sure that when you are setting your level of complexity, it's coming through. So the different levels of complexity, this is the most simple. It means it's completely ignoring mullions, which would then mean the mullion family is not going to come through. So you would have to use the roof family to bring pieces through. And this is all very specific to a Revit user. If you only use the VE, all you'll know is that I need to redraw it, basically, because it's not there. And one thing that we have mentioned before is that your ability to take out 2D views from Revit if you need to. If you are not able to get it in no matter what you do, and the architect that you're working with is someone that you may not normally converse with, or it's working through a third party and you don't want to, you can't get that information back, you can always ask for those details instead of having them revise the model and draw it yourself. So that's always the thing. It's trying to figure out where is the best time spent in what I'm putting into this model. Is it spent working to re-import it, or is it spent cleaning up what I have or redrawing it inside of the VE? And shading surfaces are something you'll run into a lot of that with. So one thing that you'll see with shading surfaces in VE that you cannot actually draw in VE is a zero volume surface. Because when we zoom in here, you can see that this plane that intersects the surface is actually just one single plane. This does not exist inside of the virtual environment. This used to be an issue when you ran an analysis, that it would actually cause an error on your analysis and say, this analysis can't run at all. But we've actually fixed that, so you can now have zero volume surfaces. The other thing that used to happen, and which is why you really need to keep the most updated version of the plugin and the most updated version of the software installed, because all of these things are consistently fixed. And that's one thing I'll always say to people is make sure that every time you're updating the virtual environment, you're doing the plugins too. Uninstall and reinstall them. And that goes for SketchUp as well. So this was a case as well where you had this 2D plane that would actually cut directly through the wall. And that would cause an issue. And those types of things have been fixed as well. So all of those intersections and problems are improved, but again, you need the updates to get that. Other things like the parapet are going to come through, which in some cases you need or you don't need. But you can actually delete these. This has been much easier to use now that you have all your shading surfaces directly inside of VE instead of as a linked file as they were before. But it also causes your file to be extremely big. So let me just give you an example of this. So this is a model that was imported. Just pull this up. And I think I've cleaned this up quite a bit. And this model, if I just go down to my shading surfaces, this I cleaned up a lot. And I have cleaned it up to 300 shading surfaces. This is actually extremely low for a model like this. If I was to import this model with high shading surfaces, I would get about 1,200. So that's why you always want to make sure that you are cleaning those up and saving, getting rid of all those shading surfaces that cause problems. So an example of a facade that I might see from Revit, and I like this one as a good example. 10,000 shading surfaces. And this is a portion of the building here. And I'm not even going to open the surface because it's going to crash. But this is a simple shading facade at the front. And that type of portion, which I actually drew a small portion of this so that we could look at it, it's a small facade example. This is something that was on a building I think it was in California, and it was meant to be shading, but because it actually had all these little holes in it, all these little sections, this type of thing is impossible to work with inside of the VE. No matter what you do, no matter what you run, you're not going to be able to even get through Suncast. So you have to make a decision at this point to say, I'm either going to simplify this or I'm going to run to fix it. I really don't want to do that, I don't think. I'm very tempted to open this to show you what it looks like, but I will resist. Also, these shading surfaces, every time you hover over your model, it's going to try to recheck to see if everyone, where they are, what their position is, all of these different details. And at this point, this model is unmanageable, and you just have to basically leave it and decide that I may want to import this on a lower level of complexity. So that's where these come in. If you go under your settings and information, and under settings and GBXML export, you have all of these different options. So what do these mean? Simple, which is the one that we were looking at before. Simple is basically going to be what we saw on that slide on the left. Here we go. It has nothing except for what bounds a room. So if you add any shading, it's not coming through. Parapets are not coming through. I'm hoping that's the same word here. And all sorts of details are just going to be ignored. Mullions, even where it divides the window, that's going to be ignored. But for an early stage analysis model, this might be what you want. You can just run it very quickly. You can pull it out. If we go to the next level of complexity, pull this up, we have simple with shading surfaces. So simple with shading surfaces does not have mullions, but it's going to allow us to then have any shading elements that we have. So we would see things like the parapet. We would see things like if we had done a roof family that was going to be an overhang over the entrance of our building, that would be included. Then we have things like complex. That's going to start to account for the divisions in the windows themselves. So it considers the mullion family, but it doesn't actually make them a shading element. Then you have complex with shading surfaces, which considers the mullions of cutting the windows into different pieces and the shading surfaces themselves. And then complex with mullions and shading surfaces. A good example of that was the file with 10,000 surfaces. I really don't know a case where I would ever use a model like that for an analysis, unless you as the engineer built it and knew that everything in there was going to be detailed and wanted it to come through. But I don't think I've ever used anything like this. You're often better to redraw that yourself because it has too much information, too much detail, and it's going to cause your analysis to run. So another thing, once you set this and you hit OK, when you go to import your model again, what will come up as the preview is going to show you what that level of complexity is. So you can check it and say, this is enough detail, this isn't enough detail for my model. However, if you do get into the model and you have a problem with this, you can always select all of these and delete them as well. So you can actually select them from this list on the left-hand side, and if it's too much, you can't even move the model. Sometimes I just delete chunks of shading surfaces once I bring it in. So that is one way to start pulling things apart. But in this case, we really wanted to look in and see if we could do a daylight analysis. So now I've said, I'm going to take a chunk of a room. This has nothing to do with my model that's going to be used thermally. This would never work for that. But what if I just want to have a view, perhaps on a floor here, looking out through a section of this? It is possible that after a very, very long run, I could actually do that. So there may be points where if you do want to actually look at a small part of a facade or a small portion of a building and see how it performs, you can actually section it off and use it that way. So you may use a portion of a model, or you may use a section of it. I've had extremely huge models that you just break into pieces and say, I'm going to use this part or that part. In the same way that you may pull out a laboratory and use that for a CFD analysis. Simple room by itself, not the entire building. Think of how you could section a Revit model to get the best from daylighting, but then leave it simple enough to use it for your thermal analysis as well. So when you bring it through, you're going to see, let's see, it comes through a little odd sometimes. So this right here is an example of layering of windows. So I'm just going to show you some things that I've seen. So often you'll get windows that come through with this issue where they may not completely align. And this is from not having a single element as a window. So here you can see that these two are not aligning. So this person had done a bunch of individual windows and placed them next to each other. Often it will cause other small issues. Like, I don't even know what that's, oh yeah, that's just the edge of the ceiling. But sometimes these will also be clipped if you have a certain type of construction, like a really thick construction applied to it. It knows to actually to clip your windows down to it sometimes. So just be careful with what you have as your defaults when you're pulling it in. You can see here that the windows are actually clipped along this edge. So what does that mean? It's kind of an interesting thing that happens when you bring in stuff from Revit. So inside of the virtual environment, if you're just doing thermal analysis, you're probably not going to use your inner volumes so much, or maybe standard-wise in your office you've decided to always use inner volumes. But in the virtual environment, you always have inner volumes defined. So even with Revit models, only with Revit. When you bring it in from SketchUp and you do a thin-walled model, your inner volumes are not defined. And your inner volumes are going to be defined by what the surface of this wall thickness is across the depth from that center line. So that's not actually a realistic inner volume, because the center line of this wall may be 4 inches from here when this is actually an 8-inch wall. So you now have an inner volume that has that depth. And that's what you see inside of the VE. So what is also happening, that if I had a wall that intersected this, that inner volume is then going to clip my windows. So it starts to redefine what even your facade will look like if you have a lot of that issues where that wall is intersecting in the middle. And that's what we're seeing with, what is that model? With that model that I was just showing. Is that's actually clipping it on the edge. And that's because of how those inner volumes are read. And the only time that inner volumes are not read from the constructions of the material itself are when you pull it in from Revit or thick-walled modeling with SketchUp. If I'm inside of the VE and I actually turn off my inner volumes and then rebuild them, they will look almost completely different, because then it is based on the construction. So if you have set up your inner volumes in a way from Revit specifically, make sure not to turn them on or off, because it will rebuild them with a different view. So if I was to highlight this model, for example, that I worked on, and turn off my inner volumes and then turn them back on, they would rebuild based on constructions. But the way they're built now is based on how the Revit model is built by those center lines. And then also, again, this is just another example of how that's clipping on the edge and the thickness of that roof slab that I had in there, or the divisions in the space. And you'll see sometimes if I have an opening in a wall, just put one of these up. So this is an opening in a wall that I have, and it's being affected by that clipping. So sometimes you can come into the model, and often if I'm going to try to clean this up, I'm automatically just going to turn off all my inner volumes because I want to see what it looks like without it. That's going to give you a much clearer view of your building. You also will have sometimes these weird like sliver spaces, and I mean it's just going to be a matter of going in and seeing, do these belong here, do these not belong here, and going in and saying, is this realistic or not realistic of my building? Okay, so the next thing we want to know is this actually going to run if I do an energy analysis? So we're going to go under settings, under model, and here are the key checks that we want to do. I'm not sure how many of you people do these when they come in, but intersections, zones, surfaces, constructions if you want to know what's applied to it, groups and textures. But you can do a check here. And it'll show up very big. But it's going to go through your whole model and say, are there any intersections between my spaces? For a very large Revit model, I bet there probably are. In this case, this one works out. Any zero volume spaces, so that could be a case where a space may be put outside or not bound but still exists in the Revit model. It's a big issue. Sometimes you can say, when you place a room in a Revit model, it will say, this room has been deleted from view, but it has not been deleted from the project. You've probably seen one of these errors come up that you you end up closing them because there's so many. But it could be a zero volume room that you have. Scanning model for openings. Zero area surfaces. That's the case where you're going to get those planar surfaces. They won't affect your model in a bad way, but it just will come up as an error. External holes. Unmatched adjacency is going to be one that you're going to see a lot with a model that you bring in. And when you close this, if you have errors in your model, it's actually going to isolate them. So what it would do is it may only show 5 rooms highlighted, and my model will be isolated by itself. And then what I can do is come in and say, all right, there's one room that's probably causing this issue because I can see it's actually surrounded by 6 rooms on each side of it. So what I do is I'll delete that center room and redraw it, see if that solves my problems, rerun my checks. But that check right there is going to be the key to telling you if you're going to have an issue when you run it or not. Okay, so now this is a model that we did import. Let's see if it will come up. But cleaned it up in a little bit of a different way. So you can see that what I did here is these planes, I did them as one surface. I made sure when I was creating this facade to not do some sort of 6-sided object with a lot of detail, and I created this so that it would be simple enough and not add as many shading surfaces to it. This one, I think, did I do this in Revit? I can't remember actually. But I mean, this is the type of thing, I think this can be done in Revit too. We did this in both SketchUp and Revit, so I can't remember if this one came directly in from Revit or SketchUp.
But not in the VE though, that's what I'm saying.
No, not in the
Okay.
VE. So you can see that some of the issues with this model is you'll still have some shading surfaces sometimes peeking through that need to be fixed, or this right here is a direct result of the healing tool where it actually comes together and will fill in a space rather than leaving a gap between the planes, which is good when you're looking at daylight. But this is the type of shading you want. You do not want to build what you have in something like this with 10,000 shading surfaces. 300 manageable, 10,000 not manageable in a project. And it just won't work. Let me just go back to
I'll just say the reason for that is that when the V is running its calculation, it's obviously calculating the effect of every single one of those surfaces. You know, so basically that's why if you're doing a sun cast calculation, obviously it's calculating how much sun is hitting those individual elements and how much is actually being reflected, or you know, how much solar radiation they actually absorb. That all of that stuff is going on, and that's mainly why the numbers of surfaces have got to be manageable.
And here's a case where this model has some issues with it that cannot necessarily be solved. And I would just have to redraw some of these spaces. Like in this case, for some reason, these two zones are connected. And there's just some cases where it comes through in an odd way. There may be a gap between the two, there may be a problem, there may be an issue, but there is a way to actually save some of this information. So if I go to an axonometric view, and I have all my window information here. So one of the things that someone had brought up was saving information about a facade. So if I wanted to redraw this, but I had my model, I can go to model it, and I might redraw a room. Make sure I'm on my... Now, this is a way to save that. When I go to my axonometric view, obviously a tall space, but if I delete that and I redraw that space, it saves this adjacency, right? So that when I go in and redraw, my windows are then stamped onto my new building, and then I can delete this piece off. So it's just a way of saving facade information and using it as a way to pull information off of a BIM model or a space that's not behaving correctly or having problems, saving what the facade is like, and then when I go back in and draw that rectangular space behind it, I have the information from those windows saved on it. So it does allow you to save and move around and kind of keep your model and keep your details in a way from that BIM model, even if the space is causing so many problems, like here I can't separate the two for whatever reason, then I can go in and use a trick like that. So I think one of the things we're always telling people is determine where your problems are and determine where you want to spend the most amount of energy on working in your project and what is going to be the best amount of time spent. Is it going to be going back to the architect if they're not receptive to your ideas? To fix it, then maybe it's going to be using portions of their model. It's going to be pulling stuff in. Maybe you're just going to keep one of the floors. Another thing that I will do a lot, as I mentioned, I was talking to someone earlier, that if I have 2 floors or 3 floors that are working very well, and that third floor is repeated up 100 times in a very tall building, and I might just fix those first 3, and then when I go into the VE, I'm going to copy up the rest. So that type of effort, you're getting information from the BIM model, but you're not saying, oh, on floor 72, I have an error, and I'm going to spend 2 days trying to fix that, when I can just focus on the ones that I need to fix, and the ones that are repeated, I copy up. So I think at this stage, it's a balance between using the information that you have, using the ones that are the most in the best condition, understanding what you may have to redraw, understanding how to save information if it's not coming through correctly, and then understanding when to abandon the model as well. In some cases, that unfortunately will be the decision. But I think that's a pretty good overview of some of the Revit issues. But all of these problems, I mean, if you have an issue with your model, I do encourage you to go to support, because they may have a trick of how to save some pieces from it or how to slightly improve that translation, and we're always working to improve it again, as I mentioned before. So certainly do not hesitate to get in touch with Sarah or I, or support@iesve.com. I'm sure you all know that. So. Right, well, thank you.
Okay, so yeah, we'll have the Q&A.
Sure.
And you said on the previous example, for you can have one single pane glazing rather than rather than doing individual panes. But in that scenario, you know, the macro flow calculations, macro flow, do you think that that may affect my calculation?
If you're inside of macro flow, you're going to want to take it out from Revit with enough complexity to have the amount of planes.
Yeah.
So if they are exporting it on, make sure that they're considering the mullions. So it could be complex with shading surfaces. I think simple with shading surfaces will show the individual panes. So at least on that level, you're getting the individual windows. The error comes when they start to do a lot of overlapping of windows, like you see in this case, where the windows are not completely adjacent to each other. And I mean, I think every case is going to be specific to really your decision as well. Like in macro flow, is this type of difference in window opening going to cause a lot of errors to your calculation in the overall building?
Depending on is it openable or not, because
Yeah,
some panes
exactly.
some panes are openable, some
Yeah.
panes are not.
Right. So if this was an operable window, and all of these were operable windows, will the differentiation in this from that affect your building? And you probably know better than I do as engineers. So it'll depend on how bad it is. If they have overlapped a lot of frames and you end up with gaps and windows that are very off, then I would, yes, highly suggest redoing it. If it's off a little bit, you have to make that decision to see, is it going to work? But just make sure in that case they are accounting for the mullions on the curtain wall. And make sure that they're drawing them in Revit, because then you will at least get a base of panes to start with. And in this case, we could just simply draw a construction line and copy it over. So it's not a hard fix. It gives you a base to start with.
Any other questions? I'm just wondering how clear people are on the things that Michelle's covered already. And if there's anything else that you wanted us to go back over. Things like the ceiling voids, for example. You know. Okay, yeah. I thought so, yeah. Something that comes up quite a lot. What I would say was on that is that it may be the case that your Revit model has the ceiling voids modelled, i.e. you have a dropped ceiling in there. Now, for the purposes of analysis, the question is, do you need those to be modelled as a separate zone or not? So do you need that ceiling void to be interrogable as a separate zone from the room? And situations where you might want to do that is where the ceiling void is active. So you have chilled beams or you have something going on in there that you want to know what the conditions are in that space. Otherwise, I would suggest that you use the, what did you call it, tying it to levels so that it takes the room volume up to the underside of the slab. So that it ignores any ceiling construction that's in there and it just considers the whole thing as a volume.
Yeah, you're better doing it yourself usually, I would say, than doing it in Revit. It's something that can be done, but again, it has to be done with the intention to create it. And has that been actually done the whole time you're doing the model? So inside of Model It, you can certainly use the cutting plane to section your spaces in both of the X, Y, and Z planes if you want. Or you can drop the height of the ceiling and add another zone on top, that type of thing. So it really depends on how you want to do it.
Yeah, I mean, I just think that in a lot of Revit models that situation exists.
It does.
So it's whether you want to bring them in separately or not.
Depends on what you're trying to model.
Absolutely, yeah. And I think that's the key too, is always asking that question, because architects often get stuck in, like, if they're doing early stage analysis when we work with them, they're like, well, I need to know the exact details of the U value of this wall. And they don't even have a very defined building form. So you figure out if that's relevant to your analysis, and then if it's not, which is the best, make it non-room bounding type of thing. If you do need to deal with it, see how good or how bad it looks inside of Revit, and then make the decision if you're going to do it on your own or use what you have from Revit.
I mean, it's the same, even if you sit down in front of the virtual environment to build the model, you're always trying to manage the amount of effort you put into modelling it against, balance that against the outputs that you're looking for. And as an experienced VE user, that's the process that you go through. Is like, well, do I actually have to model every single curve, or, you know, does that curved ceiling, does it actually make any difference to my thermal simulation results? And asking those questions, because you want to get away from the situation where you're spending 4 weeks building a model down when you could only be spending a week, you know. And it's the same sort of thing. I guess if you're in the lucky situation where you have that close working relationship with architects, and you can say to them, look, can you do these things in the model, because it will make it so much easier for me to be able to just import it. Now, what benefit is there to them in doing that? That's another discussion. There'll always be a question of how much simplification of the model is practical from their point of view, you know? And so things like shading, I would suggest, is probably easier to persuade them to simplify. But when it comes to things like, when you were talking about the layers, either wall constructions or floor constructions and things, they're going to need those in there for some you know, for the reasons that they're in there in the first place. So asking them to make those changes may not be that practical. But it's, I mean, this goes back to what I was saying at the beginning. The technology is more or less there. Now what needs to start being taken on board is really changing mindsets of individuals and changing the processes, you know, which are currently in place. So the processes are going to be much more collaborative, much closer working relationships between the architects and the engineers, more sharing of information, and the change in the mindsets is really about education and training, really. So when, you know, we see a lot of firms adopt things like Revit across the board, and as of next month every project is going to be Revit, and nobody really knows how to use it, or any of these other things that we're talking about here, any of the other purposes that data can be put to. It's not built into the way the processes are currently working.
So are most of you using Revit MEP as well, or are you just getting the model and importing it? It's kind of a mix, or is it just saying I'm getting it downstream, or do you actually have a copy of Revit in your office?
A lot of companies that I know
Will
I'm
have
familiar,
it, yeah.
they're starting to sort of
Okay.
try and use Revit on
No,
projects.
that's good. I mean, at least there you have a reason for it as well, that you will have that updated Revit model for your own use.
Yeah, I mean, there's 3 options really, isn't there? There's either push back to the architects and ask them to make the changes, or rebuild it in Revit MEP, which has its own benefits because you'll use that will be a productivity tool for you to schedule all your components and do your stuff, or rebuild it in the virtual environment, which is really not the ideal scenario. I know that's what some companies are kind of reverting back to, but we want to try and move away from that and either work with the Revit architecture or be rebuilding it in MEP if it's impossible.
But being versed in it's not a bad thing. I mean, having someone at the office that can look at the Revit model and have a copy of it and open it does often help and make it a little smoother.
Can I ask a question about Autodesk? Why aren't they inventing or making their own virtual environment software?
Well, they might be, but I mean, that leads on to another discussion, which is really about what are the risks and what are the benefits of having everything in one package. Companies and individuals and designers want to be able to use the most fit for purpose tool, and that could change in the course of a project. You know, there's new things coming out all the time. So there's an uneasiness about having everything in one, all your eggs in one basket, put it that way.
I understand that. I think I'm a complete novice and I'm a contractor. We employ design teams. So
Yes.
From our point of view, it's from a sort of standoffish viewpoint, it seems like you have a product that works on its own, and you're trying to fit it into a virtual building, and so you're trying to tailor your thing to fit into the BIM process. I mean, it was already in the BIM process. I appreciate that information.
Just say what you want to say, it's fine.
Well, it just seems that it's getting quite complicated that you're trying to tailor, somebody using a Revit model. I mean, my view is that we're trying to get our design teams to build a virtual building.
Yes.
So that we can test and look and
Sure.
coordinate and
Absolutely.
price and stuff. and most of those most of the software that bolts onto the initial models seems to work fairly well.
Right.
If not with a little bit of specialism, but not much. But this one seems to be quite difficult or different, I think.
Yeah, I mean, I think because it's data structures, really, completely different data structures that we're working with. And I mean, thermal simulation by its nature isn't really a straightforward, it's not like costing, really. It's not like we assign a cost to every single thing in the project and we add it all up. There's a lot more involved in the calculations, obviously. And so that's where we are at the moment with the GBXML. And that's the point of having this session, is to just have an open forum and say, this is where we are. These are the workarounds, these are the hints and tips. If you follow the guidance that we've got, it'll work. But yeah, there are a lot of issues cropping up.
It's like the simplification of the model which
yes.
you require for your system kind of looks like a Navisworks file, which is something that's with lots
coordination.
of data stripped
Yeah.
out. But it's still the same building and it still has data. Is any work being done on that, with that view that you could take the simplistic model and still apply?
Well, that is one option, but again, that's back to Autodesk, really, if I'm understanding you properly, to have a button in there which says, save me a model for export to whatever, not necessarily our software.
I mean, I think we have to be aware, too, that Autodesk does have some of their own products that do this, and they have the same issues. I mean, it's with Ecotech or Green Building Studio, and it tends to focus more on the architect end. There's other products that focus more on the engineering end as well, and most of those are left out by them for whatever reason. They prefer the others, but it's because I think in costing you're doing a takeoff of a wall. With energy analysis, you need a simulation of a building form that will actually hold airtight, so that the physics of it can be analyzed in this kind of virtual world, and that requires a different level. Everyone has issues with it, from their software to our software to any of the other products in the market. And but it's something, whenever anything starts to move earlier in the process, it's a learning process for everyone, and I think it'll get better. And
yeah, I mean, I'll just kind of finish off that point, and then there's a question at the back. I mean, my point on that would be, look at it from an MEP point of view, Revit MEP point of view. Where are we now with Revit MEP? Is it a fully usable and tailored package for the UK market? Right, so that's the danger, the area when you enter this kind of notion of having everything happening in the one model. Whose interests are going to be looked after in developing that, And obviously we're an international company, we're doing different things in different countries with different environmental rating schemes, and we're trying to keep up to speed with all of those things. That's the strength that we can bring, so that's where people want to link the two together. Yes?
Hi Sarah, I have two concerns. First one being, I'm working a main contractor environment, and we appoint consultants, architects. I'm looking at the advantages with respect to getting the structural engineer to develop the Revit module so as to mitigate any duty of care issues across the board. So if the structural engineer does the Revit model, he interfaces with the MEP consultant and the architect and the client to ensure that you get homogeneity and involvement from all parties. So for one, I would like to get your view on that, on the duty of care issue, mitigating any errors. And the second thing is actually looking at elevations that might have two plant rooms on, say, a 20-story building that would have louvers, and allowing free air supply into that area. And if you have any examples of how you model those spaces.
Okay, the first one I'm not sure that I can answer. The duty of care on having the different...
If the structural engineer does the Revit model for the team, then that could be transferred over to the MEP consultant. He put in his details, and then that gets sent over to the architect. That way, the structural engineers have all the pressure and strength of the of the columns and floors.
Yeah.
The MEP guy will get all the systems in, and the architect would do all the finishes and doors. By looking at that integrated approach, rather than each person doing their own model,
Yes.
and having errors, me being the client, I'm interested in making sure that there's no errors on either part. So it's saying what's the advantage, if you see it as a big advantage, having the structural engineer
Yeah.
doing it first.
I don't know about that. I mean, normally the architect starts the process off and develops a concept, and then the structural, with Revit, because it's it's a single platform, so they're all sharing the same central model, if you like. Then the structural engineer starts to develop his structure on the basis of what the architects, and the same for the MEP, they'll pull in the architect's model and they'll build their systems into that model. But yeah, I mean, I think Revit's ideally suited to that situation where you have the enhanced collaboration, the coordination. It should reduce the number of RFIs and problems and things that happen on site.
I mean, I think that with specifically for that, in regards to what you use our software for, all these different linked models, like we might get one from the building facade designer and one from the interior architect and one from the structural engineer, and all of these come together to one file. We just have to make sure they're all room bounding, and that's our big concern with it. So as long as they're linked together, and if you do have a model like that, make sure you send us all the linked files, is my comment on that. But it does work. There is probably more propensity for small gaps or things that are slightly off when putting volumes in, but it completely works. And that's where products like Navisworks come in to start to check for intersection errors, and that my beam and my plumbing are not crossing each other and having to be rerouted in the field. So yeah, it certainly works. But again, our biggest concern is to say, how does this all come together and form a shell, an airtight shell that we can analyze as a physical object and become part of our analysis?
Yeah. And I mean, the way that we would just model those plant rooms with the louvers on them, and we would, if we were then doing analysis on the amount of free air coming in through the louvers to cut down your cooling or whatever, then we would take that into account. Yeah. That's what we do, yeah.
What I'm really interested in is, once you've done the analysis, how can you pass that back into the BIM environment? What export is available?
As yet, very little. So we can't take the model back in yet. All we can take in currently is heating and cooling loads back into Revit. So they, yeah, and they'll appear in the room data, which you can then, obviously the engineers then use that for doing their duct sizing and plant size and stuff.
And that does help. It is something, we have it on the forum, and we can put it on the help information of how to import that data back in, so it fills out on your schedules and your room information. So, but I mean, it's, with that available, you can imagine there's a lot of other things that could be available in the future.
Yeah.
So.
But I mean, I don't see a point where we take any geometry back in. I mean, because if you look at the difference, the simplicity of a VE model versus a Revit model, I mean, and it's not the same thing at all, because Revit's object orientated, it's a relational database behind it. The VE is a completely different animal when it comes to geometry. So yeah, so it'll be more likely to be results rather than the geometry itself that we would take back. What you'll find, though there's moves afoot at the moment, there will be massive changes in the way that things are happening, as she says. So I wouldn't, from a client point of view, I wouldn't get too hung up with likes of Revit, for example, because there are other means of exchanging data and extracting information and, you know, reporting that, I suppose, from a client, and populating asset management, facilities management databases and things.
I mean, if you're a client too, there is something kind of interesting that's free from Autodesk. I forget the name of it, but it's a viewer that you can download for free, and you can view a three-dimensional model. So if you have people that are working in Revit, it's worth asking for that, so you can see your model and what it looks like. So yeah, there's moves towards that, and maybe one day you'll be able to even select a room, look at the results from it, that type of thing. Yeah. And I mean, if Revit has those capabilities later, our loads information is imported back in, that will appear on those things. But I know that they're definitely working on that too.
Imported into that, or?
IFC is a language. It's not a program as such. It's a language. So it's like, I mean, it's kind of like that, but it's much, much more comprehensive. That's all stuff that we're looking at the moment. Yeah.
First we're going out, then we're doing the studies to bring it back in. But that is something that can be imported and exported from Revit. So, and Revit right now doesn't have an import.
IFC.
Yeah. I mean, I think they do now, but they don't have an import GBXMO, as far as I know. But so that would probably be the one that would import data back for you in the future. But that is something that I can assure you we're working on.
Yeah,
so.
Yeah. It's all about, I mean, this is where I'm going to wrap up at the end, but it's really about, from a designer point of view, thinking beyond the 3D model. Because it's building information modelling. It's the information that we're really interested in now, in exchanging that between different packages. And that will be the next generation of what we're doing. GBXML is like the first generation. We're moving forward in that respect. It's worth looking up, reading up a bit about IFCs actually. It's used quite a bit in America. The GSA, no?
Yeah, they're requiring it more. They want to get into it. I mean, especially because they want to create a standard, but also in Europe, where I'm working in, from Scandinavia especially, they really want to say, let's make a standardized file format that we stop saying everyone has their own flavor of this file format, and it becomes, you know, you can't adapt to everything. So they're trying to create testing standards for output right now. Import will be later. And they're doing that through a group called Building Smart. If you're interested in looking that up, there's a lot of data on Building Smart.
I'm quite interested just to know, before we sort of finish up, with the what we've covered today. I mean, I'm guessing obviously people are trying to implement this. I know, having spoken to some of our customers, that they are trying to implement it. Has what we've covered today given you any comfort, reassurance, information that you think will be useful when you go back and try and do this the next time? I'm looking at Jose and Janet there. Yes? Okay, good. You know, how successful so far have your efforts been? I think I know the answer to that anyway. Not very successful, would that be right in saying? Yeah, okay. And so hopefully we've covered a number of the issues that you typically come up against when you're trying to effect this integration. Is there any other questions or anything else that you'd like us to cover that you've come up against that, you know, it's just you're banging your head against a brick wall?
And I think, as far as I remember, in one section you said you have to say adjacencies. So, for example, in that scenario, how do you deal with the basement or car park, which is unheated? Yeah, okay, so what, the fact that they are... Like, you want to treat the ground level as, the first level as a ground level, because this is actually your ground floor. Because probably that's the area you want to insulate. And the floor below is actually unheated, it's just the... So how can you actually... you just model it without... So you actually... Okay. Yeah. I thought you were asking about the adjacency of the ground to those spaces, because obviously the heat loss, etc., would be different. Yeah. And you can do that in two ways. Whether you do it in the VE or Revit is another question, but in the VE we would either set the adjacent condition to be a temperature or a temperature from a profile, or we would just build a sort of buffer. I'm just kind of wondering what you need to do in Revit environment. Just model it, that's all. Okay. So it comes across as a space, and then you can decide how you treat it in the VE.
Yeah, I mean, one thing with Revit to remember is also remember where your levels are set. So if you have an actual elevation, which relates to this, if you say I have an elevation of 250 feet above sea level, and that's where my first floor is set, first thing you want to do when you get into the VE is just open the viewer of the model. So half the time you're going to see that the model is actually floating 250 feet above the ground plane. So that's one thing to look at. And make sure that it is actually set on the actual ground. Like in this case, you can see this is a perfect example of that, where it's actually above the ground here. So this is just, but it's because they put in the actual elevation for it, so that needs to be moved back down. But in Revit, it doesn't, I mean, you're going, since you're going to set your constructions and everything when you go into IES and the adjacent temperatures, all of that's important. It's just making sure that your model's at 0. Anything that you build below 0 will be below grade inside of IES. So you're just building it the same way as you would build any other room, but below 0 elevation.
I mean, you can come and grab us after we finish,
Yeah.
or, as I say, put on your feedback form if there's anything that we haven't covered today. And I'm very interested in future topics as well. So,
And anything that you would like actually written out on how to do in the feedback, because we're going to write these down and send them out too, so that if something you want to remember how to set up.
yeah, explained. Okay, I'm just going to wrap up with a few points. Obviously, feel free to add anything, Michelle, if you want. First thing I've got down is to think beyond BIM as 3D CAD, so think about information. There will be, as I say, drivers towards a standardised approach in how Revit and other BIM models are created so that they can be used downstream. That's key. There's lots of uses for that data. Obviously, we focus on energy and environment, and that's what we've covered today, but again, there'll be other purposes that those models have to be put to. It is early days. We've tried to, rather than highlight the shortcomings, we've tried to give you some practical advice to deal with the issues that you will encounter, and it will get easier. The technology is, I'll finish with that point, the technology is more or less there, but people and process now are the big things that need to be changed, and I'm sure you're encountering that as well.
So the only thing that I would add is today we approached it in a very realistic way. Instead of saying, oh, everything's going to be perfect, I want to say that expect that there'll be issues, but also know that there's ways to fix it and that you can get there at the end. It's just that sometimes I know that you encounter maybe marketing or different groups that will say, oh, it's going to be perfect. Just hit the button and the model comes through. So you do have to expect issues, but it's not just you, it's not your firm, it's not your Revit models necessarily. It's just working through it, figuring out the best way to set things up, and it should be fine.
Okay,
Right,
thanks.
thanks.
Thanks very much, Michelle. Thanks,
Thank
everyone.
you.
Hopefully speak to you soon. Thank you.
Yes, bye.
Right.